So Jolene and I would like to introduce Dr. Greg Bulté. Greg got his first degree at a Cégep in Sainte-Foy, and I'm going to totally massacre the French name, but I'm going to do it anyways. It was Techniques d'inventaire et de recherche en biologie, or biological inventories and research in French. Okay, I didn't totally massacre that. He then went and did a Bachelor's of Science at the University de Québec at Trois-Rivières. I'll keep working on it. It'll get better. And then he did his PhD at the University of Ottawa with Gabriel Blouin-Demers, and his thesis was on the causes and consequences of sexual size dimorphism in the northern map turtle, which is work that I know some of us are still citing and enjoying today. He then did a postdoc at Carleton University with Mark Forbes, which was actually on fish parasites. And in 2011, became a biology instructor at Carleton University, where he's a really integral part of the Department of Biology. And so with no further ado, I would like to welcome Greg to come give our first keynote talk.
All right. Hello, everyone. It's good to see you this morning. I know some of you had a lot of fun last night, so it's great to see some faces this morning. I'll try to keep you awake. I know coffee was late to come, so yeah, I'll do my best. So I'm really excited to be here today for a few reasons. This is where I work, so that makes it extra special for me. It's also a privilege in itself to be able to give one a keynote address at CHS. But also, I think for me in particular is I just can switch my slides. Come on, worked earlier. Will I have to do this way? Okay, remote is no longer working. There we go. Okay. So one of the reasons that makes it extra special for me is I gave my very first talk at a scientific conference at a CHS conference, actually at CarkNet, the ancestor of CHS. And that was in 2003 on Pelee Island. And that summer I had done a little project on burying beetles feeding on snake eggs with Gabe and Pat Weatherhead at the biostation. And the story of how I got to give that very first talk back then is actually the same story of how I got into map turtles in 2003. So this year's, and the reason I think I find quite special to give that talk is that this year is the 20th anniversary of our map turtle study in Lake Opinicon. And this is a female, this is the 11th female map turtle that we've marked in the lake. It was marked on June 4th, 2003, and I have a picture of her because I caught her again this year and last spring. And berry change, only grew a couple millimeters, no noticeable change in her. However, the person marking her has changed a little bit. You get to decide if it's for better or worse. So this is the one picture of me of my first summer at the biostation. And so I want to take a few minutes to tell you how I got into map turtles, because I think there's an interesting story, especially for maybe the younger folks in the crowd here. So that story starts not in 2003, but in 1998. So this is me in 1998. I was starting college degree to become a biology technician. I'm dressed as a butterfly because that was the day of our initiation. We had to sell candy on campus dressed as butterflies. And some of you might recognize this fellow here. That's Dan Pouliot. Dan has been involved in CarkNet and CHS a lot over the years. And we met in that degree in 98. And we very quickly bonded over a shared interest for natural history and herpetology. And as fate would have it, in 1999, CarkNet met in Québec City, where we lived. And so I actually didn't really know what a scientific conference was then. But all I knew is there was a bunch of people that were going to talk about herps. And so I signed up. We both signed up, actually, Dan and I, and we went. And that turned out to be one of the very important decisions in my career, because I met two very important persons at that conference that I can link directly to why I'm here today and why I have my job as an instructor and why I keep working on map turtles and able to give this talk today. The first person is Karen Molinas. So Karen, probably none of you know her. She worked for a park in Maryland, a small county park called Jug Bay Wetland Sanctuary, where they were doing a lot of herp research. And she gave a talk about the work they were doing there. And at one of the breaks, I went and talked to her. And she told me about an internship programs they had at the park. So I applied, I got it, and I spent the last the next 2 summers tracking snakes and turtles and doing bird bending at Jug Bay, and got a ton of field experience on all kinds of things. And so that was extremely formative for me. Now, the other person I met that was important for me at that meeting is this fellow here that probably a lot of you know, Gabriel Blouin-Demers, that is now at the University of Ottawa. This is what it looked like back then. And at the time, he was finishing up his PhD on gray rat snakes. And I was super excited to see him there because in my mind, this guy was a celebrity because I had seen him on the Discovery Channel. So in 1999, like just actually a few months before the conference, I had seen this documentary. I think it was on Daily Planet at the time. And it was this guy like with, hearing and a beard. It was like tracking snake in the woods and finding where they lay their eggs and doing all this cool field research stuff. And it was in Canada, which is really what blew my mind. Like normally you see people doing that, I don't know, in Venezuela or like some exotic place. But this was happening like right in Ontario. So I was like, I need to know how to do this. This is what I want to do. So when I saw him at the conference, I was really excited, and I went to talk to him, found out that he's actually Francophone, and we went to the same high school. And that interaction with him, that initial interaction combined with the experience I got in Maryland, led me to a few years later be hired by him when he got his first job as a prof at the University of Ottawa. And he hired me to come and help with his snake and turtle research at the biology station. And that's when we started marking map turtles in Lake Opinicon. Then I ended up doing grad school with him, did my PhD, and that led me to get this job. And I never stopped studying map turtles ever since. So all of this, because I went to a conference when I was an undergrad, or even before my undergrad, and I talked to a couple of people at a break. So that's the lesson here, of course, is don't be shy to talk to people. We're all a bunch of herp nerds that like to talk about herps, and that's the reason we're here today. So conference is just starting. So if there's people you want to talk to, take advantage of this time and go introduce yourself. You never know where it's going to take you. All right, so let's get into our map turtles. So this is a picture of a female northern map turtle poking its head out of the water, and she's at a communal hibernation site. This picture was taken in the fall, around this time of year. And if you go there at this time of year near a map turtle hibernation site, you'll see a lot of heads poking out. It's a really fun thing to do. You go with a canoe or a boat and just sit calmly, and then you see all these little heads poking out. Because there's a lot of turtles under the water, and they periodically come to the surface to breed, of course. And just before the hibernation period, of course, during the hibernation period and right after, the life of map turtles is largely underwater. So until recently, it was pretty hard to know what was going on during those pretty important parts of their life cycle. But in the last 10 years or so, there's been all kinds of new technologies and new tools or things that have become more affordable and accessible that have allowed us to start looking under the surface of the water and under the ice to see what's happening. And so that's what I'm going to be talking about today. Now, I need to make another acknowledgement here, and that is I'm actually not a researcher. At least that's not what my job description says. This is my job. I'm an instructor. It's my job is to design and teach undergraduate courses in biology here at Carleton. It's an excellent job. I love it. It's very fulfilling, but it's not a research position. I don't have a ton of time to dedicate to research. I don't have a ton of resources to dedicate to research. So I wouldn't be able to do any of the work. I would not have been able to do any of the work I'm going to talk today if it was not to a whole roster of collaborators that have supported the map turtle works over the years. So I'm not going to go over every single one of them, but these are all people that have been crucial in keeping that work alive over at least the last 10 years or so. So I'm very grateful to every individual in these pictures. So I don't think of myself as a researcher so much as a map turtle peddler who's trying to sell map turtle projects to actual researchers. So that's kind of how I feel about myself most days. All right, so my talk's going to be in 4 acts that more or less correspond to the title of the talk. And they're all going to converge to one bottom line. And that bottom line is that in winter, map turtles face this trade-off between meeting their demand for oxygen and minimizing or avoiding predation risk by river otters. And this trade-off has shaped their mating behavior and has important implications for their conservation. So probably most of you are familiar with map turtles, but this is what they look like. One of their key features is this extreme sexual size dimorphism. So in this picture, we have 3 turtles. The big one's a female, the 2 little ones are males. They're all mature. There's no overlap in size between male and females at maturity. So females are about twice the length of male, about 10 times their mass. And they're a fairly sort of, let's call it social with quotation marks. So they're gregarious would be a better term, turtle. So they really like to hang out with each other. They form large basking aggregation. And as you will see, they form large overwintering aggregations too. So I'm going to spend a couple of minutes talking about our study system in Lake Opinicon. So this is where Lake Opinicon is located. So it's along the Rideau Canal between Ottawa and Kingston. So Rideau Canal links the Ottawa River to Lake Ontario. It's a network of lakes connected by canals. Lake Opinicon is one of those. And this is where the Queen's University Biological Station is located, which is a fantastic spot to study wildlife and herps in particular. Hopefully you get to make it to the field trip on Monday. And if you're contemplating field sites, this is an amazing spot. So Lake Opinicon is about 9 kilometers long. It's not very wide, maybe about one kilometer or so at the widest. And it's probably as small as a water body you're going to find map turtles in. Which makes it great because it's a trackable system as opposed to, map turtles hang out in Lake Ontario, the Ottawa River, the St. Lawrence River. It's hard to have a more finite population you can work with these large open systems. So in a smaller lake like that, it's great because we can keep track of most turtles. And one of the amazing things they do is that every year they do this sort of seasonal migration towards one point in the lake. So in the early years of my PhD, we've put transmitters on about 60 turtles, and we've tracked them over 2 years. And if we make a heat map of where these turtles are hanging out in the lake based on about 3,000 locations, we get this map here. So basically, they're all over the place. There's some hot spots. There's definitely some little bays they prefer, but you can find a map turtle anywhere in the lake. Now, if you go look for map turtles in the same lake in November or October, you're just going to find them there. So there's almost that fission-fusion dynamic where they just aggregate this sort of pulsing things that happens every year where they converge toward one spot and then they disperse all over the lake after. And so what I'm going to be talking about is what's happening around that little island in the late fall, winter, and spring. And it's a super convenient spot for us because the biostation's right here and my cottage is right there. So this makes an ideal study system for me. And so because we have a bunch of turtles at the same place at the same time, it makes it relatively easy to catch a lot of them. So if you go to the hibernation site right now, you'll see a lot of rocks like this where they're completely covered in turtles. You can see a bunch of heads poking out of the water there. And so if you put your snorkeling equipment on and you get in the water, and you can catch a lot of turtles, especially in the early spring. So this is sort of what a half an hour of snorkeling for map turtles in April will get you in Lake Opinicon. So we can, by myself, I can get 40 to 50 turtles in about an hour snorkeling. My limiting factor is, in fact, how many turtles I can process and bring back in the lab by myself, because I do most of that field work alone. If there was 5 of us catching map turtles that time of year, we'd get 200 turtles a day. But by myself, I can't. Of course, then we take them back to the lab, we measure them. Sometimes we have guest celebrities coming and helping measure turtles. This is, of course, Nick, who came and that was after the CHS meeting from Montreal, I believe. Nick came and hung out at the biostation, and we went and we caught map turtles at the hibernation site there. And then we marked them. Now we used to notch them, now we pit tag them, and then we let them go. This is my wife, Sandra, who's been very helpful to come with me in the spring when there's nobody else on the lake and I'm swimming in 4 degrees water. So there's somebody watching for me in case I have a heart attack. She's well aware that she's going to find me dead in that lake at some point, but that's I think she's okay with it. So over the years, we caught about 2,000 individuals, about 4,000 captures. Population size, actually Mark Masral is helping us with some population size estimates, but it's probably in the neighborhood of 2,000 turtles or so. And one of the cool things you see if you snorkel at the overwintering site in the early spring and late summer is that you see them mating. And this is pretty classic for most turtles in this area. The mating season tends to be fall and early spring. It's probably just normally a fall mating season, but it gets interrupted by the winter up north. And so when you dive in these areas or snorkel in these areas, you often see females being chased by males and males courting females and so on. And so that leads me to our second act, which is reproduction. So back in 2004, when I first started snorkeling there, I was really interested in trying to document some of these behaviors, but by snorkeling was kind of challenging. Turtles are deep, you spook them all the time. So it was hard to collect systematic observations. But then we got a 3D printer in the department, I think in 2015 or 2016. And so I pounced on it and started 3D printing map turtles. And then we used them to do field experiment to try to look at the mating behavior of males. And the way our setup worked is that we had these sort of rigs in which we attach turtles, and there's a GoPro on top filming down. And so this is sort of the view you get once the turtles are deployed in the water. And then males readily came in and interacted with these fake turtles. So we focused on the behavior of males because they were very responsive to the models. And so some would mate with them, some just came and checked them out. Sometimes they would bite them. So there was all kinds of interaction going on. So we sort of developed a system to score these interactions. And then we designed some experiments to test hypotheses about the mating behavior of males. So one of the first thing I was curious about is, are male choosy? Because we have a very interesting situation here where there's virtually no cost for males to look for a female. They're all in the same place at the same time. So it's really easy for a male to locate a female. They don't have to swim kilometers to find them. And there's definitely more females in one area that any male can possibly mate with, especially considering that they don't produce sperm during their mating season. The sperm is all in reserves because they produce sperm in the summer. So one thing we thought maybe males might be choosy in regard to is size, because there's huge variation in size in adult females. There's small females, there's big females, and there's probably a relationship between female size and fitness, at least as far as offspring size goes. So this is a hatchling map turtle from a small female. This is one from a large female. So we have about a twofold range in body size of offspring. And then, probably, at least based on some studies, larger is better for baby turtles, at least in the first few days of life. So we thought maybe if males have the choice, they might go for the larger females because they have so many mating opportunities, so they might start discriminating. So we did experiments with fake females that are sort of average size versus some that are about the tail end of the distribution of size in the lake. And then we looked at the mating behavior of males, and we found that males prefer larger females as we expected, which is sort of consistent with other studies in other taxa. But there's not only just a lot of females there's also a lot of males. And so we were curious too about, do males adjust their mating behavior in relation to other males? And one thing they might want to try to do is avoid sperm competition. And there's good evidence that there's a lot of sperm competition in this population of turtle. So Nicola Banger, who did her master's degree with Steve Lougheed and Gabe at U of O, did some paternity analysis in map turtles. So she looked at, I think, around 30-something clutches, and about 71% of them had multiple dads, usually 2 or 3. So there seems to be a lot of sperm competition. So then we wondered, well, do males try to avoid sperm competition? And so we did a follow-up experiments in which we put females of the same size, but some were surrounded by rival males, so fake males versus females on their own. And then we looked at what males were doing. And then we found out that they avoid females with rivals. They tend to hang out more with females on their own. So we think they adjust their mating behavior to reduce sperm competition. So having this aggregation of turtles seems to really affect the mating behavior of male. They're choosy. They also try to avoid each other to some extent, at least as far as we can tell from these experiments. Now, this is all done. It's been published. I've talked about it, so I won't say much more about this. But I want to talk a little bit about the other stuff we sort of seen that we've never published on this, that doesn't have enough information to be published. But I think there's some interesting stuff going on. So one of the things we've been seeing is females would also sometimes be interested in our decoys. So here's a female, and this is sped up about 10 times. And then she's going to go and check out the smaller decoy. And then let's give her a little bit of time here. She's gonna check it out. All right, yeah, all right. That's not who I thought it was. And then things are gonna get a little bit more interesting. Like, oh, who's this? All right, well, I don't know about you, but this kind of looks like mating to me. And, you know, when the first time I saw something like that, I was like, oh, this is interesting. Like, is there, you know, it might just be some kind of strange, rare behavior. No, it's actually fairly common. So we ended up seeing a lot of females mounting our decoys, sometime doing something that looked like mating, sometime rubbing their chin on their back. So there seems to be, at least as far from these experiments, some kind of female-female interactions going on. The function of it, I have no idea. Is it some kind of dominance thing? I don't know. So it would be really interesting to see some follow-up work on that. And so another thing that we were able to document here is, as far as these female-female interaction, is that we've seen in one instance a female vocalizing at another female. Now, vocalizing is not a new thing in turtles. It's been, it's relatively new, but it's now I think it's pretty accepted that that's a thing that a lot of turtles do. But there's not that many field recording of turtle vocalizing. And so I'm gonna play a little video here. I'm gonna unmute my computer. Hopefully it's gonna, ooh, okay, let me turn that off for a sec. Okay. All right, so it's very, very faint. It's going to play out of this speaker. It's a little squeak. So when I start playing the video, I'm going to say, go, be really silent and count in your head up to 5. And at about 6, you're going to hear squeak and the turtle's going to jerk and squeak at the same time. Okay, so let's see if we can hear it. It's very faint. All right, so I'm going to unmute myself, unmute this, and then here, and then stout. You can hear it though. It's definitely there. I can play it for you if you didn't hear it later. But yeah, this is definitely something I think somebody should follow up on. So, anyone? All right. So no, I think there's something interesting there, and I hope somebody look at that. All right. So now we're going to move on to the winter. So of course, after the turtles are aggregated and they're mating, then the winter settles, and then they're stuck under the ice for the winter. And one of the critical things that seems to affect what they do in the winter is oxygen. And what I'm going to be talking here about is the masterworks of Jessica Robichaud. So Jessica just finished her master with Stephen Cook and Heath McMillan. I was co-supervising her. And she did some great work on the under ice behavior of northern map turtles in our lake. So well, the first thing you learn when you start looking into overwintering of map turtles is that they are anoxia intolerant, which is just a fancy way of saying they can't survive an entire winter without access to dissolved oxygen in the water. So if we look at the duration of ice cover in Lake Opinicon, it ranges around 100 days to 150 days, so almost 5 months of ice cover in a cold winter. This is how long a northern map turtle can survive without oxygen when submerged in water at 3 degrees Celsius, about 45 days. It's pretty impressive in itself. I mean, it's not painted turtle impressive, but it's pretty good. But it's not nearly as long as winter lasts. So bottom line here is that they absolutely need to seek habitat that have dissolved oxygen in the winter if they are to survive. So what Jessica was interested in is the behavior of map turtles in relation to dissolved oxygen during hibernation. And to do that, Stephen Cook got us a bunch of accelerometers, which are these little devices. There's actually two things in there. There's a radio transmitter that allows us to recuperate our other device, which is the accelerometer. The accelerometer measures the movement of the turtle in 3D, so pitch, yaw, roll, and also measures depth and temperature every second during the entire duration of their hibernation. So she put 40 of these things on turtles. We got data back from 33 because a few crapped out during the winter. And she started looking at their behavior in relation to dissolved oxygen at the overwintering site. And this is what dissolved oxygen looks like at the overwintering site of map turtles. It's pretty classic for a lake. So here we have dates. The gray box is when the ice is covering the lake. So, we have saturated oxygen early on, so around 100%, and then it decreases steadily during the overwintering period. And then towards the end, we're in sort of hypoxic territory. Not quite anoxic, but definitely hypoxic. By the way, this data was obtained by, I think, something like 7 or 8 submerged loggers that were recording dissolved oxygen every minute or so. So this is not just dipping at YSI a few times during the winter. This is thousands of data points. And she tried to look at the relationship between dissolved oxygen at the overwintering site and the behavior of turtles. And she didn't find anything. She didn't find that dissolved oxygen, at least the decline in oxygen, affected their behavior whatsoever. But it still matters, and I'll explain why in a bit. But she was able to get some really good descriptive data on their behavior under the ice. The first thing that I thought was pretty amazing is that they are active throughout the winter. So we knew from anecdotal report that they could move around in the winter a little bit, but we didn't expect them to be as active during the winter. So again, the gray box is where the ice is on, than before. So they remain pretty active, and they're active even when there's little oxygen in the water. So this in itself, I thought was pretty cool. But seeing a graph like that shows activity. Oh, by the way, I didn't explain what this axis is. This stands for overall dynamic body acceleration. This is just a measure of how much a turtle is moving. So basically, you can see that it's the same before and after the ice is on. So turtle keep the same level of activity. But seeing a graph like that, I was like, yeah, this is cool, but I really want to see them. So the following year, I put together a time-lapse camera that I submerged under the ice at one of the overwintering sites. And I had it programmed to take a picture every day for the entire winter. Unfortunately, for some reason, only worked in November and February, but I was still able to get some images. And this is a premiere. I've never shown this publicly before. So this is what it looks like in the winter. So if we play a video here, it's a time lapse, 1 picture a day. So November, not much going on. There's not many turtles. I might see 1 or 2 showing up. Then we jump to February, and it's darker because there's ice, snow on the lake. But this is what it looks like. So there's loads of turtles, and they're constantly moving under the ice. And note that they're also exposed. So map turtles don't bury themselves in the sediments. They remain exposed, and that's because they use their skin as a gas exchange surface in the winter. So they need to be exposed to survive the winter, and that's going to become important later. Now, another thing we found is that they're shallow. So in the winter, before the winter, they hang out in deeper water. They'll sometimes go fairly deep, but then as soon as the ice sets, they move in shallower water and they hang out at about 1 to 2 meters depth, and they remain at that depth for the entire winter. And because they are shallow, they are also very cold because the colder water is going to be at near just under the ice, of course, because the warmer water is going to be at 4 or 5 degrees at the bottom of the lake. So closer to the surface is colder. And then this is their temperature. So basically this is following the water temperature of the lake. But then when the ice forms, they actually go to the shallow and they hang out near 1 degree Celsius, some of them under 1 degree. So just before between 0 and 1. So they're really cold. So there's probably some, this is probably an adaptive behavior. So by seeking that cold water, they decrease their demand for oxygen because they basically behaviorally reduce their metabolism. So it's kind of a behavioral metabolic depression. And of course, if you hang out in colder water, you're going to be exposed to higher concentration of dissolved oxygen because colder water retains more oxygen. So it's probably a strategy to both reduce their demand for oxygen and be exposed to more dissolved oxygen in winter, which might be one of the key things why they can survive the winter without being tolerant to anoxia. So basically what we've learned from these studies that map turtles, from these studies that at hibernation site map turtles are aggregated, they're exposed, and they're shallow. This is not necessarily a good thing because that makes them extremely vulnerable to predation. So if otters can get into their overwintering sites, that would be an all-you-can-eat buffet, and that would be really easy to have a pretty big impact on the population. And of course, so that's my last act here. So of course, we all know about the potential effect of otters on turtles, especially in the winter. And most of what we know of this is, of course, the work of the Algonquin folks, including Matt Keevil, who's revisited that data recently and showed that, you know, predation by river otter can lead to very long demographic consequences. So they can be pretty, they can have a pretty huge impact on turtle populations. Now, there are otters, of course, where we work. This is one of them here. So this is a trail cam that I've put around the overwintering site of map turtles last winter. The time-lapse videos you've seen, so these turtles are about right there. This happens to be actually a spot that I think there's some sort of resurgence or underwater current. So the ice tends to be thin there, and I think that's why otters visit that spot. And I wonder if it's actually one spot by which they might be able to enter the lake. Now, the reason why I've put that camera there last winter, it's because the previous spring, when I went snorkeling, this is what I happened upon. So this is me filming while I'm snorkeling. This is on the 21st of April, 2022. First time I was in the water that year. Really excited to go catch map turtles for the first time. And this is what I started seeing. Little piles of dead, mutilated map turtles all over the place. We ended up recovering from that day 154 carcasses, so probably around 10% of the estimated population size, at least from our earlier estimates. This is a subset of them. A lot of them looked like this, so clearly predated by something. The smaller ones were crushed. The bigger ones were just like dismembered. Luckily, it seems they seem to have targeted mostly the smaller males and the young females. So we didn't find any adult females, which makes this even more catastrophic. But it's still a major predation event. So that really led me to think a little bit harder about, you know, what would happen if these kinds of events were to repeat themselves over time, because we know from our long-term study that map turtles are extremely faithful to these overwintering sites. They go back every year. So I've been catching some of the same turtles for nearly 20 years coming back to the site. So they are very, very faithful. And unfortunately, being faithful to a particular site may not be the best strategy in a rapidly changing world. And there's a good review paper that's been published on that very recently called Site Fidelity as Maladaptive Behavior in the Anthropocene. And they basically make the case that, you know, sometime when the environment change, going back to that place might be maladaptive, but animals may not have the behavioral flexibility or the time to mount an evolutionary response to avoid that behavior. And this is essentially the Bart-Simpson syndrome that can't get over his desire to eat a cupcake, even though each time he wants to grab it, he gets a shock. So eventually it will decrease his fitness. And so if animals keep going back to sites that are becoming sink, then we can have some massive population decline. Now, is there any reason to think that the environment is changing rapidly enough for map turtles? I'm not sure, but I'm going to speculate a little bit. One thing that I'm wondering if it's happening is that I'm wondering if otters are becoming more common in the lake, or actually in general. I was clued into that from a trapper who traps otters in the area, who's actually a naturalist. And he was like, I'm really worried about turtles, you know? I was like, oh yeah, why? He's like, well, I've been trapping a lot of otters in the last few years. Like, oh, tell me more. And then so he told me that otters have been increasing in the area, and he thinks it's because the price of pelts, so this graph shows the price of otter pelts over the last 20 years or so, has been declining quite steadily for around $100 a pelt to, you know, maybe $10 a pelt. And the harvest has basically mirrored that decline. So people are not trapping otters anymore. And of course, we killed all the wolves, so there's nothing to eat them. So I'm wondering if otter populations are in an increasing phase throughout Ontario. Now, another reason we might be worried is that ice phenology is changing rapidly. There's been a lot of review papers about this in recent years. Of course, climate is warming, you have more extreme warming towards the poles, and so we're losing lake ice. So we might provide more opportunities for otters to get into these sites that maybe map turtles had originally selected because they're sites that protects them against otters. And of course, we have to keep screwing things up even more. So I don't know, anybody knows what this thing is? You do? Exactly, yeah. It's an ice bubbler. It's essentially a propeller people put underwater near their docks and boathouse, and it shoots water up and it prevents the ice to form around their dock. So this is actually one of my neighbors at my cottage has one. So they can create these massive open areas around docks and boathouses. And of course, that might provide some entry points for otters, but it can also completely change the underwater dynamic of the water. And so thankfully, so far, there's none that are close to our overwintering site in Lake Opinicon, but these things are spreading like wildfire. So a couple of winters ago, my neighbor and I hiked a bunch of the lake, and then we documented 20 of them. And this is on a lake where they're not even allowed. So the Rideau Canal does not allow these things, although they don't do anything to enforce it. So I'm really wondering what happens in lakes where they are allowed. I know that every new cottage owner wants to buy one of these things because they get told that if they don't, the ice is going to mess up their dock. People have had docks for 100 years in these places, but anyways, that's beyond me. And so I'm really worried about these things. And I think anyone working on turtles in lakes where there's a lot of cottage activity should also be worried about these things. And again, I won't put my turtle peddler sign here, but I think that's something that should be followed up on. All right, so this is my bottom line again. So I hope my talk here was able to illustrate that map turtles face this interesting trade-off between meeting their demand for oxygen because they're an oxygen tolerant. And so to meet their demand for oxygen, they need to be shallow, exposed, and aggregated. They're aggregated because there's probably few sites where they can survive the winter. But then that makes them vulnerable to predation by otters. And of course, that can affect their prospect for long-term survival. So we'll leave it here. And hopefully I'm not super late. I think I'm all right. All right, happy to take some questions.
Okay, I'm just wondering if when you talk to the cottage people that are using those alligators, are they receptive to the work you're doing with the turtles, and would they think about not using them?
I haven't individually reached out to people. I don't feel comfortable doing that. But we've tried to advertise it on. I'm part of a cottage association that has some very dedicated people, and I brought that up to their attention, and they've been posting on social media about it. And in fact, I know of one instance of somebody who stopped using one. But I think the main issue is people just don't know, and there's the rules are really, you really have to dig to find these rules. And so I think people buy docks and then they go to these dock places and they suggest that, yo, you should put a bubbler. And then they're like, all right, because your $40,000 dock is going to be broken. And then they put these things in. And I actually went to a dock store one time to buy some cleats, and I saw them. And I was like, are you aware those are not allowed in the Rideau Canal? And I was like, what? So like nobody knows the rules. So I think Parks Canada, if they are worried about these things, they really need to step up and advertise their rules better.
I was wondering about the bubblers and if you think maybe they might have the opposite effect. It's opened up the ice and perhaps making more oxygen available, and the turtles might spread out and not all be aggregated in one spot now.
Yeah, that's a good question. I did wonder about that. And the question was, could bubblers actually be beneficial because they oxygenate the water and maybe create more suitable habitats? Yeah, I did wonder about that. The reason I don't think it's the case is because there are actually sites that are open water in our study systems. There's a few sites where there's enough current coming in that always have open water, and those are probably the best oxygenated sites in the lake. We've never had a single map turtle overwintering there, probably because they would be extremely vulnerable to predators. So I think that's the reason why but time will tell, but I honestly think it most likely going to have a negative impact than a positive one. Yeah. Fred? Sorry.
Non, c'est moi qui ai le micro.
Oh, sorry. Okay. There's currently.
Très belle présentation, Grégory. And I also wanted to thank you for doing what you're doing. I think there's a lot of students here that are wondering how they can do research outside of a faculty position. And I think your dedication to research over the last 20 years should be applauded. Great.
Oh, thank you, David.
I do have a question. So map turtle, but I'm sure there are other turtles. I'm not familiar with the site at all, but what's the story about the other turtles in the lake when it comes to predation and oxygen? Do you know anything?
We're starting to know a little bit better for some species. So pine turtle seems to mostly go wherever, and snapping turtles too. There seems to be aggregations of musk turtles, are also an oxygen intolerant species. They don't congregate in the hundreds as we see for the map turtles, but they seem to be more like scattered in one little bay. And we did a pilot project, Nick, Steve, and myself last winter, where we put transmitters on 9 of them to figure out where they spend the winter. 6 of them got picked up by minks. And then a few of them we found in cache with a bunch of other dead musk turtles. And I also look at the mink trapping data, and it's the same thing. Prices dropped, harvest has dropped, and so I don't know. Is there more mink? I can't answer that question right now, but there seems to be a lot of predation happening.
Yeah, what about all the river systems where there's not very many map turtles, like the South Nation and the Rideau? Do you have any idea what controls the populations there?
I don't, but if I can speculate, I think one thing that might be a limiting factor for them is overwintering sites. Just seeing what we know from Lake Opinicon, what people have documented in the Vermont to in the Lemoine River, is that they form these massive aggregations. So there may not be suitable sites, or maybe some of these, maybe there historically was, but then they were altered in some ways, and then. Because I think if anything happens to these sites, you can really see a pretty rapid decline.
So I've got a question from somebody online. Cheryl asks, are the turtles ever surfacing for air throughout the winter?
Oh, that's a good question. Under the ice, it doesn't look like they are, but we could potentially try to look at that. So there might be some air pockets right under the ice. And the analysis that Jessica did looked at average daily movements and activity. If we were to take, because we had measurements every seconds, we might be able to see if there's actually little quick migrations under the surface. But yeah, we haven't looked at that yet, but that's a good question, probably.
So I'm the agitators is one issue, but I'm wondering about climate change. Have you looked at what the local climate models say about what's going to happen to ice cover on Lake Opinicon?
No,
because that could have a similar kind of an effect.
Yeah, no, I haven't looked at climate. That's a little bit outside of my wheelhouse, but There's been one of the former managers, so the data I showed was collected by him, and there's not really a trend within that time window, that 25 years or so. There's some good years and some bad years, but there doesn't seem to be a trend. But studies that have been more exhaustive with greater temporal coverage and greater spatial coverage often found a decline in the ice cover period in temperate region. But I haven't looked specifically for Opinicon. I think it's not so much a problem if the window of ice shortens. It's more like if the ice become unstable in the winter. I think that's where problem can start, I think.
That the squeak, the squeak, was that made under the water or out of the water?
Underwater. Yeah.
Underwater squeak.
Underwater
Wow.
squeak. Yeah.
Awesome. Okay.
Yeah. And the audio is really bad because it was only recorded from the audio of a GoPro underwater. So
Great talk. Thank you so much.
thank you.
Since you're so good at 3D printer, like very realistic turtles, I was wondering if you could run a Bart Simpson trial on the otters, like make the models taste really bad and put them all over so they'll eat the models and really get an aversion for turtles.
Yeah. That's an interesting one. I actually been thinking a lot about not for that purpose, but to just document predation, especially on the musk turtles. If we could like put 200 fake musk turtles submerged underwater. Problem is I haven't thought about a way to make them in a material that it's that can be that will register bite marks and that would not sort of disintegrate underwater, over 4 months. So maybe wax, maybe is one thing, paraffin or something that's not toxic, but that also can keeps its integrity, but register bite marks. So if you know of a material we could use for that'd be great. But yeah, that's the idea of deterring predation with lots of fake turtles. This could be interesting.
I'm just thinking of material that they make baby toys out of. If babies can bite on them, or dogs, those chew toys.
Right. Yeah, that could be a good one. Just a matter of mass producing it for a reasonable amount of money.
They have an aversion.
Yeah.